All right, so last time we were talking about the derivative, right? We had just started that, and I had shown you that we were going to try and reach this final conclusion, I guess the direction of where we're going, all right? And the whole concept comes from the idea that we would like to know what we refer to as the instantaneous rate of change of a function. Instantaneous rate of change. Now, the way we do that is we look at 2 points on a curve. We connect a straight line through them, and we call this the secant line. And we can easily compute the slope of that line. But what we're interested in is not the slope of that line, but what's happening at exactly, if we come down here, and we call this right here x equals a, all right? So at this value a, it might be 5, it might be -2, whatever it is, you give me an x value, I go up to the function, I put a dot there, and then I try and imagine what the line going through that point would be. So what I'm going to do is I'm going to drag this point over closer and closer and closer until I get right on top of that point, and when I get right on top of it, I have what's called the tangent line. The problem with that is that when I try and do that computation, I get 0 over 0. But now we have the limit, so we can get around that. Okay, so that's where we were at the end of class last time, and I actually gave you the formula that we'll need in order to do this. All right, so that's what we're going to pick up. Were there any questions on homework or anything else? Just remember, our goal is to find the slope of a line on a curve at a single point. And I don't think I talked about this last time, but I did refer to this when we were starting this course. The reason we're interested in being able to find the slope of this line is because there's certain points on this graph where the slope of that tangent line would be what? What would the slope of the tangent line be at these 2 points? 0, right? The slope would be 0 because they would be horizontal. The tangent lines would be horizontal. And so it turns out that if somebody gives you a function and you would like to know where the highest points are and the lowest points are, then what you have to do is figure out where the slope of the tangent line is 0. In other words, you're going to have to solve an equation. You're going to have to set something equal to 0. But we still haven't looked at what it is we're setting equal to 0. It's not the function. Because what do we get if we set a function equal to 0? If I just give you this red function, here it is, and I set it equal to 0, what are you actually getting?
The intercepts.
The intercepts, good, the x-intercepts. What I'm telling you is to find the highest and lowest points on a graph, we have to figure out where the tangent line is 0, which means we have to set something equal to 0, but we still don't know what that is that we need to set equal to 0. Does that make sense? But it's not the function, it's something else. It's called the derivative, and that's where we're headed, all right? So let me get the lights back on. That's all I was going to use that animation for, just to make sure everyone understood visually what we're trying to do. I'll turn this off. I don't think we need it. Do you mind hitting the light, the projector? Do you see that black panel? Bottom left corner says off.
Yeah.
Okay. Yep. There you go. Thank you. All right. So last class, we said that the slope of the tangent line to a function f at x equals a is, and here's the slope. It's m. Remember we used m for slope in the past? Back when we were doing y equals mx plus b, that's the equation of a line. M was always the slope. So the slope of a tangent line to a function at some point x equals a is m, and I will subscript it with tan. That way you know I'm talking about a very, very special slope. It's the slope of the tangent line. is equal to the limit as h goes to 0 of f of a plus h minus f of a all divided by h. I suggest you memorize that formula. It'll make your life a little easier the sooner you can remember that. So in 1324, hopefully you did enough of the difference quotient that you kind of already have that in your brain. And all we've done now is we've added this one element, h going to 0. And remember, the h going to 0 is what we need to slide that second point on top of that first point. We need that limit. All right, this is it. Time to do some examples. Okay, so the first example, you're given in this problem a function f of x equals, let's start out very basic here, 5x plus 3. I would like for you to find the slope of tangent line at x equals 2, x equals 5, and x equals -1. So I actually want you to look at 3 different points on this curve and give me the slope of the tangent line. Does anybody have an educated guess as to what we're going to get for the answer for all 3 of those? Like, what do you think the slope of the tangent line is going to be at those 3 points for that specific curve?
It's going to be a straight line.
Well, this is a straight line, right? Okay, so shouldn't the tangent line be the same for all of these? Because it's not curving around, right? The original function is not curving around. Do y'all agree with that? So if I graph that, it's a line. Let me just show you. It would be a line like this. Okay, it would have a positive slope of 5, have a y-intercept of 3. So if I go to any point, right, if I go to 2, or if I go to 5, or if I go to -1, does it make sense that the tangent line would actually be, the slope of the tangent line would actually be the same as the slope of the line? Does that make sense that it would? You sure? Okay, so this is a very, very, like, I don't want to say ridiculous example, but it is, because we would never need to find the slope of a tangent line of a line because we already know the answer. But what I want to show you is that this computation should give us 5. All right? It should. Let's see if it does. All right. I forgot to add some notation. I didn't do it last class. I should have started with it today. This right here, this limit, which is the slope of the tangent line, is so important to us now. We have a special notation so that if you ever need to refer to this, you don't have to write all this out. Okay? So I'm going to write the special notation for this right below this. This right here, limit as h goes to 0 of f of a plus h minus f of a over h. We have notation. Here's the notation. This is f. Okay, that would mean that's the function's value at a, right? Yes? And this is not the function's value at a. This is the slope of the tangent line at a, right? So all we do to let you know I'm talking about that is I put a little what we call a prime mark. Okay, it's like an apostrophe. It's just a little, we call that prime. So the way you say this is f prime of a. F prime of a is the way you say that to someone. And this is called the derivative of f at a. Okay? This is all new language that we're going to be using in here now. So if I say, hey, I want you to find the slope of the tangent line at a for this function, I'm asking you to find f prime of a. Or I'm asking you to find the derivative of f at a. All 3 of those things mean the same thing. Okay? Yes? All right. So over here, back to this example. This first point right here means that we need to do f prime of 2, right? F prime of 2. So for x equals 2, here's the work. I need to find f prime of 2, which according to this formula, 2 is the a, right? 2 is the a. And so I'm going to put that there and put that there. So let's write the formula out and see what we get. Limit h goes to 0, f of 2 plus h minus f of 2 all over h. Make sure I'm on camera here. Pretty close. Okay, any questions? What I did here? Just using the definition with the given, I'm about to use the function here. I'm going to have to erase this. Okay, continuing over here, that is equal to the limit as h goes to 0. Now, what does f of 2 plus h mean? I mean, what does it mean I need to do? Y'all okay today? Y'all all right? Are y'all lost, or are you just tired? What's going on? Tired? Okay, so what does f of 2 plus h mean you need to do? Plug in 2 plus h into that function for x. So I'm going to replace that x with 2 plus h, right? So that's going to be this part in blue is going to be 5. And then 2 plus h, 2 plus h. What should I be doing with this 2 plus h? I haven't done it yet. Parentheses around it. And then what? Plus 3. Okay. So we have replaced this x with 2 plus h. That's just evaluating this function at this value. Have to have the 2 plus h in parentheses. Y'all good with that? Okay, now I need to put a minus sign. So minus. And then I need to do this part. F of 2. What does that mean? Plug 2 into the function, right? Now that I can do. That I can just plug in and get an answer, can't I? So let's just plug 2 in here. 5 times 2 is 10. Plus 3, we should have 13, shouldn't we? Okay, 13. Any questions? I'll color code this just so you can see it. This part's the blue part. This part's the red part right there. Okay? The blue and the red. And then the very important subtraction sign between them. Now all of that has to be divided by what? H. Okay, so we put h here. And now, I hope that in 1324 your teacher told you that when you're doing the difference quotient, which is this part, forget the limit, that's the difference quotient. When you're doing that, that if you do it correctly, you should get everything up here to clean up and just have every single term up here should have at least an h in it. Were y'all told that? I know I told my class that, but when you clean up the difference quotient, you shouldn't have any numbers by themselves or x's by themselves. Everything should have at least an h. So let's see if that happens here. We get limit, h goes to 0, and then let's distribute the 5 through. So we get 10 plus 5h plus 3 minus 13 all over h. So all I did there was distribute it through. And what happens there? Do you see it? The h cancels? Not yet. Let's not do that yet. Remember, a long division bar means I have to clean all of this up first before I can do any division. So canceling this h right now is not a legal move. You're not allowed to do that. But you can do something else. All the other things will cancel out, right? You got 10 plus 3 is 13, but then take away 13. So this, and this are gone, aren't they? And at this point, now you could cancel the h, but I'm not going to do it yet. I just want to write the next line. We have 5h over h. And notice that your numerator has something in it that has an h, and that's what we want. All right? So at this point, I can cancel the h's, and all I'm left with is this. I'm going to still write the limit. Limit h goes to 0 of 5. Now, if you look at this, and you say, okay, look at that 5 right there, and let h go to 0. Well, there is no h, right? There's no h left. So h going to 0 has no impact on this. So the answer is just 5. And we're done. That kind of matches up with the picture, right? At 2, the slope of the tangent line is actually equal to the slope of the line itself. You all with me? Okay. The next thing I'm about to do is really important. So let's see if I can convince you that this is a good idea or not. What if somebody wanted us to do this at 5, at -1, which we would have to do that 2 more times, right? But what if they gave us like a list of more numbers, 7, 20, and they gave us like maybe that many to do, right? They wanted to know the slope of the tangent line at all these different points. Now, we know the answer is going to be 5, but let's say if it was a different function, right, then we couldn't say 5, and we would actually have to compute this 1, 2, 3, 4, 5, 6 different times. And I don't think any of us feel like doing this limit 6 times, right? Right? So maybe there's a shortcut. Maybe there's a shortcut. Maybe what we can do is instead of looking at these 6 different things all separately, why don't we just say, let's find the slope of the tangent line at some arbitrary value of a. So I'm not going to actually tell you what a is yet. I'm going to tell you a after you do all the computation. Then I'll tell you what a is, and you can plug that in here and tell me what the slope is. If we do it that way, we only have to do the limit 1 time. So let me illustrate that with this example, all right? So what we'd like to do now is focus our attention on finding the slope of the tangent line at a instead of a fixed number. So this really means we want f prime of a, right? That's what we want. All right, let's write that out. Let's write the formula for f prime of a. F prime of a, by definition, is limit h goes to 0 of f of a plus h minus f of a all over h. So the difference now between what I did with 2 and what I'm doing here is that I'm not able to plug 2 in for a, right? I'm just going to leave a as a variable, right? A is just going to be a variable. So we continue. Limit h goes to 0. And now I need this top left corner, f of a plus h, which means I'm going to do what? Plug what in? Plug a plus h into the f of x, which means replace that x with a plus h. Okay? So I'm going to write that down. It'll be 5 parentheses a plus h plus 3. Yeah? So that's my little blue part. Now here's a very dangerous part right here, and this is the part that a lot of students mess up. I'm going to subtract now. From my formula, I need to subtract. I need to subtract f of a. Now in the previous problem, when we did that, it was f of 2, and that was just the number 13, right? But here, f of a is not going to be a number. It's actually going to be this with a replaced, or the x replaced with a, which means it will be 5 times a plus 3, right? 5. Now, when I put that here, 5 times a plus 3, I must put that in parentheses. And that's the part that students forget. Because the subtraction sign, you must subtract both terms, so put that in your parentheses. We clear? Sure? That's the red part. What am I missing still? I still have something else I need here. All over H. Okay. Equals limit. H goes to 0. Now at this point, let's start to clean the expression up. When I distribute the 5 through, what will I get? 5a plus 5h. Then I still have plus 3. And then when I distribute the negative through here, minus 5a minus 3. Good. All over h. Now, when I do this, at this point, things should clean up top. Is that a question? No? Okay. Things should clean up in the numerator. And everything that's left, when it's done cleaning up, should have at least one h in it. And everything behaves very well here, right? Doesn't it? And all that's left is 5h. Again, (5h) over h. And then the h's cancel. And the limit as h goes to 0 of 5 is just 5 again. So what this tells me is that if I'm trying to find the slope of the tangent line of this function at a, the answer is going to be 5, no matter what a is, right? Because look at this answer, it has no a in it. It just has 5. So regardless of where we go, regardless of what x we pick, we're always going to get that slope of 5. Make sense? Okay. That's only for this function because it's a line. All right. So now let's tweak it. Okay. Let's change the problem and see how things get messier. All right. So what I'm going to do now, very simple change. We're going to go to the next example. I'm going to just square that x. And you can no longer rely on the slope of the line always being 5. Right? Y'all agree? Okay, so let's start this as a new example. I'm going to leave that up there because that's our definition of our derivative. So here are the instructions for this problem. Find f prime of 0, f prime of 2, f prime of negative 3, and f prime of 5. You have two options at this point. You can go and write down the definition for all 4 problems and do the limit on each of the 4 problems, okay? Which will take you some time to do. Or you can find the general derivative at a for that function and then use that answer to answer these 4 all like one after the other, okay? So I like the second option. I like going to this. Is that all right with you if we do that? It's actually where we're going to be going anyway. Like we want to get what's called the general antiderivative. Sorry, wrong class. We want to find the general derivative. All right. Antiderivative is Cal 2. You do integrals, you go backwards. Yeah. Okay. But all right. So let's do this. We're still using this formula, right? The only thing that changes is that when we plug a plus h in, it's actually what are we plugging it into? Right? And this is what we're plugging it into this time. And that squared is going to have a pretty dramatic impact on the way things go. So you ready? Let's do it. So f prime of a is equal to the limit as h goes to 0. Don't leave the limit off, okay? The limit needs to be here. And now, the blue part, we're going to replace x over there with a plus h. So it'll read 5. A plus h what? Squared. Okay, that time it's squared. Then plus the 3. Okay, so just replace that with a plus h. Then the minus sign. This is our blue part. Our red part is coming. What is it? F of a. What is f of a? 5a squared plus 3, right? So I need to put that here, but in parentheses. All over h. All right. Now this is obviously going to be a little more work, right? I mean, like previous problem, we didn't have the squared, so we just distributed the 5 through and just went on our way, right? But order of operations says that we are not allowed to multiply these together until we have first done the exponent here. So I actually have to take a plus h and square it. So I'm going to do that on the side. I'm going to do that like little scratch work over here. What is a plus h, that quantity squared? Well, that means a plus h times a plus h. It does not mean, okay, this does not mean a squared plus h squared. When you square two things that are added together, you do not just square each one of them and add. That's not true. Y'all agree with that? Y'all believe that? You've been told that? Okay. Sometimes in math, you just have to convince yourself. What is this? Well, that's 5, right? That's 5? What's 5 squared? 25. Okay, now let's try and do it this way, where you just square each one atom. What's 2 squared? 4 plus what's 3 squared? 9. That's what? 13. That's not 25. So this squaring of each one is a bad algebraic move. You have to do this. Okay? So this you have to do your FOIL, a times a squared, a times h gives you plus ah. And then you have the inner one, which is another ah, and then the last one, which gives you h squared. Now this computation is going to happen several times in your homework. So in your homework, I think I may do it once, and then every time after that, I just say, hey, this is the end answer. I don't go through this work every time. Okay, so here we can combine these two like terms together to get 2 ah's and then plus h squared. So a plus h squared is equal to a squared plus 2ah plus h squared. Good? Okay, that's what this is. But I still have a 5 in front of it. So when I rewrite this, I get 5a squared plus 2ah plus h squared, close my parentheses, that's this piece replacing this, plus 3. And then can I just distribute the negative through there? Yes, okay? Because the only squaring that's happening here is on the a, and it's not like this where I have to expand it out. So I can freely distribute the negative through the parentheses, and then I do all of that over h. And things are still not canceling yet. I'm going to erase this. What do I need to do next? Distribute that 5 through. So this is equal to the limit, yes, keep writing the limit, 5a squared plus what? 10ah plus 5h squared, keep going, plus 3 minus 5a squared minus 3, all of this over h. Now, if you did things correctly, good things should happen here. Things should cancel, and everything that's left should have an h in it. So I see a 5a squared minus a 5a squared. I see a 3 and a minus 3. And nothing else goes away. So I'm just going to check real quick. That has an h in it. That has an h in it. So I'm okay. I like that. So this is limit h goes to 0 of 10ah plus 5h squared over h. Now right now, if you let h go to 0, what would happen? If you just try and take this limit, do direct substitution, you would get 0 here, 0 here, and 0 here. So you would have 0 over 0, right? And we said when you have 0 over 0, you want to try and do some algebra, something to simplify it. And in this case, factoring an h out of the top is the algebra we need. That's why I was really wanting h's in both of these, because I can just pull an h out of the top. So if I factor an h out, what am I left with if I pull one single factor of h out of the top? What am I left with here? 10a plus 5h. And now these h's can cancel. And we're almost there. We're almost there. So here's what we have. We have that the limit as h goes to 0 of 10a plus 5h. Right? That's what we have left. After these h's canceled, it's just that, right? Now, finally, at this point, let h go to 0. What happens when h goes to 0? 5 times 0 would be 0, right? And you still have what? 10a. So the answer, no more limit, right? No more limit, because I actually let h go to 0. The answer is 10a. So notice that this answer has a in it, right? That means this right here was the f prime of a, right? This is saying that if you want to know the slope of the tangent line of this function at a, you need to actually know a, and then multiply it by 10, and that's the slope of the line. So if I go back here, I can answer all of these questions, all, what, 1, 2, 3, 4, I can answer all 5 very fast now. Okay, what is the slope of the tangent line for these 5 now? So f prime of 0 is 10 times 0, right? Which is 0. And then what's the slope of this one? 20. This one? Negative 30. And then finally 50, right? The slope of the tangent lines. Yes?
What happened to the 5h?
Okay, so at this point right here, I said I'm going to take my limit. What happens when h approaches 0? When h approaches 0, this becomes very close to 0. 5 times that basically vanishes away to nothing. And all that's left is this, 10a. So we never applied the limit until the very end of the problem when it would kill off one piece. See, we can't, I erased it, but we couldn't do the h goes to 0 when we were back here because we were getting 0 over 0. But after that algebraic move and canceling the h's, we were able to do it. Okay, what do y'all think? Yeah? So look, I was going to graph it and put it on the projector, but let's see. This function right here, if I were to graph that, it would look like this. It would be up 1, 2, 3, up 1, 2, 3, okay? And it would be a parabola that opens up like this, but it would be a very, very steep parabola because there's a 5 in front, so it makes it a very narrow parabola. What we just figured out is that if you go to 0, x value of 0, right here, 0, and go up to that point, see that point right there? And you find the slope of the tangent line, it's going to be what? 0. And that makes sense, doesn't it? Look, the slope of the tangent line there is flat, it's 0. Yes? If I go out to 2, which would be like 1, 2, and go up to my function and find the slope of that line, it's going to be 20, right? So very, very steep. Remember, slopes of tangent line or slopes of lines. This is a slope of 0. This is positive slope, right? You're looking at it. This is negative slope, right? And when we talk about positive slope, a slope of 1 is a perfect diagonal. So if your slope is 1, it's a perfect diagonal. Slope of 2 is steeper, 3, 4, 5, 6, 7, 8, 9, 10. And so really, a slope of like 1,000 is almost vertical. A slope of 1,000,000 is really close to vertical. Do y'all remember what the slope of a vertical line is? What's that? Undefined. That's right, it's undefined. Oops. Vertical lines have undefined slopes. So the bigger this number gets, the steeper it gets. And if it's negative, it actually goes the other way, like this. So does it make sense that I got 20 here? And if I go out to 5, which would be further to the right, 3, 4, 5, I'm going to go up, I'm going to have a really, really steep line, right? And it's actually going to have a slope of 50. I go to -3, I'm on the other side, and now that slope is pitched down. It's a negative slope, very steep. Okay? Sure? I have one more thing to say about this example. And this is, again, this is where we're headed with this, so this is the way I want you to think about it. Let's say I put that function on the board, and I said, hey, look, I'm trying to find the highest and lowest points on that graph, okay? I'm trying to figure out where its highest point is and where its lowest point is. And act like you don't know what it looks like, okay? Can you do that for me just a second? Act like you have no idea what that looks like. Then, if you're going to try and find a highest or lowest point, you're going to want to know when the slope of the tangent line is 0, right? Yes? What is the slope of the tangent line for that function? We just did the work for it. What is the slope of the tangent line for that function? 10a, right? It's 10a. So we know that the slope of any tangent line on this function is 10a. If I want to know where the highest and lowest points are, then I need to know when that is 0, right? When is this 0? And so what I need to do is take 10a and set it equal to 0. Now, what's the only number you can multiply by 10 and get 0? 0. So that means a must be 0. So what this is telling me is that if I want to know where the highest or lowest point of that graph is, I need to go look at the x-coordinate of 0. And there's where I have a flat tangent line. And that should correspond to either a lowest or highest point. Does that make sense? And I can do that without actually even knowing what that looks like. And that's what we're going to be trying to do as we proceed. I give you a function, we don't know what it looks like, but can we find the highest and lowest points? And going back into business, the application of this is if you have a cost function or a profit function or any type of function, you are interested always in these highest and lowest points. And we can use this sort of method to find those highest and lowest points. All right. I think it's worth another example. I'll leave that up there. All right, here we go. Example, you're given a new function, f of x equals -3x squared plus 2x minus 7. Find f prime of 0, f prime of 4, f prime of -1, and f prime of -3. Now let's take a quick vote here. We have two options for this. I can work this whole problem out right now on the board, or I can give you an opportunity to work on it in groups and see if you can get to it. Do you feel like you have enough right now with the formula and what I've done to try and go after this? So how many of you want me to work the whole problem out? Wow, thanks. So how many of you want to do it on your own? Yes? That's enough. Okay, so let's do this. I'm going to give you, I don't know how much time. It's 10:10. Let's see what you can do in 10 minutes, and I'll do a check on you and see where you are. But I want everybody working. I want everyone writing. I want to be able to come by and see your algebra. I want to see, good notation. All right? Okay, have at it. on. Okay, so you should come up with negative 6a plus 2, right? That's what you should get. So a couple of the things that I noticed going around is, when you're plugging in a plus h into this function, you have to be aware of, it's going to go here and here, right? Not just one place, but two places. And you still have to square that, a plus h, which means you have to do the FOIL, and then you have to put a plus h here and distribute a 2 through it. So just be careful for things like that. The minus sign in the formula, be careful again. I didn't see anyone make a mistake on that. Everyone had minus, and then they had the parentheses around that, so that was good. So I think a majority of you got to this. That's a good sign. Now we still need to answer the questions. So what's f prime of 0? 2. So all you're doing is going to that formula and replacing a with 0. This one, replace a with 4 over there. What do you get? Negative 22. Here, be careful. If you replace a with negative 1, you get what? Positive 6 and then plus 2, so you get 8. And then here, 20, right? So you go negative 3 here. It's negative and negative is positive. That becomes 18 plus 2 is 20. Any questions on this? You sure? Okay. Let's do one more thing on this one. I'm going to add one more question onto this problem. Here it is. Find the equation of the tangent line at x equals negative 1. Yeah. We have not done this yet, all right? So what is the difference between the question I'm asking there and the question that I'm asking here? This one is asking for the slope of the tangent line at 0, the slope of the tangent line at 4, the slope of the tangent line at negative 1, the slope of the tangent line at negative 3. This is asking for the equation of the tangent line, right? Different. That's totally different. You have slope, which is just the pitch of the line. The equation is the actual function that would draw that line.
So we're just working backwards. Would we?
Well, I'm not quite sure what you mean by backwards, but maybe. We need to come up with the equation of a line, right? And that line needs to be the tangent line to that curve. So what do you need to come up with the equation of a line? What information do you need in order to come up with an equation for any line? You either need 2 points or a single point and the slope of the line. So there were different formulas, but does this formula look familiar? I know we've used it already. We reviewed point slope formula of a line. Look like this: y minus y1 equals m times x minus x1. Remember that standard formula from 1324? This says, hey, I can give you the equation of any line. If you just tell me the slope of that line, you tell me a point on that line. Right? Okay, do we know the slope of the tangent line that we're looking for? What is the slope of the tangent line at negative 1? 8. We already did that work, didn't we? So we know now that this number is actually the 8, right? It comes from the negative 1 right there. Yes? All we need now is the actual point. And where does that point have to be?
Or anywhere on line.
Anywhere on... Think about the picture again, the pictures I've been drawing. we first start out, we would draw the function, right? This would be a parabola, it would open down, wouldn't it? We went to some x value, we went to -1, and we found the slope of that tangent line was 8, didn't we? We know the slope of this line, but do we know a point on that line? Wouldn't this point right here work? And that point lives on the line and the function, right? Both. So all I really need to know to figure out this point is the point that corresponds to the x and y on this function. What am I really saying? What am I really saying to you? If you want to know the x and the y coordinate, do we know the x coordinate of the point, that point that's on that curve?
Yeah.
What's the x coordinate? -1, right? How do we figure out the y coordinate?
You just plug it
We plug -1 into
in. F of x.
the original function. And wouldn't that spit out the y coordinate on the graph? Okay, so when we're looking at this, what we're going to do here is for this is just going to be -1, right? We're just going to put -1 right there. But this one, we're actually going to have to plug -1 into the function to get that y coordinate. Into the original function. Not into the derivative, but into the original function. So let's do that work on the side. Do you all follow what I'm saying here? You need a point on the curve, which we've got, and we need the slope of the tangent line, which is 8. So can you tell me what this y1 is going to be? y1 should be f of -1, which should be -3 times -1 squared plus 2 times -1 minus 7. So we got to compute that. So what does that turn out to be? I've heard two different answers. What does this piece turn out to be right there? That's -3. What does this turn out to be? -2 or -2, and then -7. So that is -12? Yes? Okay, so what we have here is, let me write it so you can see it as a point. x1, y1, right, which is a point that lives on this curve, is actually -1, -12. That point lives on that curve, and that's where our tangent line should be. Yes? Yes? No? Maybe? Okay, so now let's plug it in here. Y minus what? -12 equals m, which is 8. I erased it, but m was 8. And then x minus -1. And what is this? I clean it up just a little bit here. Minus and minus is plus, so y plus 12 equals 8 times x plus 1, because again, a minus minus is plus. And let's solve this for y. Let's get it into that nice form, y equals mx plus b. So I'll distribute 8 through. And then finally subtract 12. There it is. All right. Just going to come here real quick. Let's see if I can bring this all together now. I'm gonna put the graph of this up here for us so that you can see exactly what we just